All right, guys, this is a big one. Taylor and Maclaurin polynomials. For today's video, you're just going to have to trust me. There are two important aspects. You need to know how to do something, and you need to know what it means, what's going on. You need to understand it. We'll take care of the understanding part in class, but for this, I need you to learn the steps. You're not going to know why you're doing them. You're not going to know what you're doing, but you need to get the steps down because the skills are half of it. The understanding is the other half. And we'll talk plenty about the understanding, but first of all, write down this formula, the Taylor polynomial formula. A little bit of trivia, named after my great uncle on my mom's side, Brooke Taylor. So there's my claim to fame. Anyway, here's the formula. This thing that we need to be able to find, it is going to give you a question, is going to give you a function that we are trying to find the Taylor polynomial based on. It's going to give you a center, which is the location that we are our home base for our Taylor polynomial, the location around which we are expanding, which again you'll understand later, and it's going to give you a degree. All right, we're finding a polynomial, a second degree polynomials, we're finding a quadratic function, a third degree polynomial, a cubic function. The degree is basically how many terms, it's going to determine how many terms are in our polynomial. And you have to find the polynomial. Okay, so don't get frustrated because you don't know what's going on. Just get these steps. We're going to do a nice ordered list here of steps. All right, so step one. If the degree you're looking for is n, you need to take n derivatives of your function. So let's start with sine x. Let me give you the question first, actually. I'm going to give you the function, which is sine. A lot of times sine and cosine trig functions are used, but they're easy ones in this context. And I'm going to give you a center of pi over 2. And let's make the degree, let's call it 6. I'm looking for a 6th degree polynomial, so x to the 6th power will be the biggest power in my polynomial, for sine centered at pi over 2. It's called a Taylor polynomial. By the way, a Maclaurin polynomial just is a special name for ones that are centered at 0. Makes it a little bit easier. And ever since Superbad came out, all my students have called these McLovins instead of Maclaurins, which is okay. All right, we'll call them McLovins if that helps. All right, so step one. We need to take 6 derivatives. Whatever the degree is in the question, start by taking that many derivatives. And you kind of form a little table, a little chart, but unofficial. You don't need lines and all that. We'll start with our function, and then we'll start taking derivatives. F prime, F double prime, all the way up to the 6th. Usually at 4th, we can go like that. Just get it set up, and then we'll start taking them. They're easy to take. The derivative of sine is cosine. The derivative of cosine is negative sine. Negative cosine. Sine, back to the starting point. Cosine, negative sine. Well, no big deal. It sounds daunting to have to take 6 derivatives, but these are usually not ones, like when you first learned how to do second derivatives, you did really crazy ones. These are not those. These are usually e's and sines and stuff that you don't have trouble taking the derivatives of. And usually you're not going to take 6. You'll take 3 or 4. All right, so step 2. What we need to do is we need to plug in the center to each one of these. We need to take the center, which is pi over 2. I'm going to add step 2 out here. because I don't want to mess with my chart. And usually what I'll do is I'll just say at pi over 2, meaning plug pi over 2 into these and see what you get. Okay, so you're going to have to remember your unit circle. Sine of pi over 2. Pi over 2 is up at the top. The sine of that is the y value of that, which is 1. The cosine of pi over 2 is 0. Negative sine of pi over 2 is negative 1. And then you get a pattern. All right, so again, we did something 6 times, but it's not difficult. All right, we're just plugging pi over 2 into each of my 6 derivatives. Now, let's look at this formula. The Taylor polynomial for the function sine at the center, which is c in this formula, of pi over 2. My first term is the function evaluated at pi over 2. Well, I just found that. It's right here. Okay? Function evaluated at pi over 2. My next term is the first derivative evaluated at pi over 2 times x minus pi over 2. Well, that one happens to just completely wipe out because my first derivative is cosine, which has a value of 0, so that term's going to completely disappear. My next one is the second derivative over 2 factorial times x minus c squared. And you just get this pattern. The third degree term is a third derivative over 3 factorial times x minus pi over 2 to the third power. It's just a repetition of this same thing over and over. And by the way, this is my 0 degree term, which has 0 factorial on the bottom, and it also has x minus c to the 0 power. It's just both of those things are 1, so it doesn't show up. My first degree term has a 1 factorial, which doesn't show up, and it has an x minus 1 to the 1 power, which also does not show up. So the pattern holds, even though the beginning doesn't quite look the same, it still is the same. Let me get rid of some of that stuff. Okay, so let's just follow our pattern. This would be, getting ready to form our answer already. P sub 6 of x means the 6th degree polynomial. It should start with the function evaluated at pi over 2. So that 1 is always my starting value. All right, that 1 right there. Now I'm going to include the 0 terms. I'll just show you how they get wiped out in just a minute. My next term, according to the formula, is the first derivative times x minus c to the first power. So my first derivative is 0, x minus pi over 2 to the first. Okay? My second derivative is negative 1. This term has a 2 factorial on the bottom, and my x minus pi over 2 gets raised to the second power. Second derivative, second factorial, second power. The next one is 0. Third derivative, 3 factorial, third power. Okay, that one, like the first degree term, is going to get wiped out because of the 0, and that's just the nature of sine and cosine. They're equal to 0 a lot. My next one's a positive 1, so I'm going to jump down a line. Fourth derivative is 1, 4 factorial is 4 factorial, and fourth power is fourth power. Okay, next one is 0. This one's going to be gone in a minute. All right, we have derivative, factorial, power. Fifth derivative, fifth factorial, fifth power, and finally I'm at negative 1 for my sixth derivative. And you can put the negative, you can do plus and put the negative right next to the one, you can just subtract the whole term either way. 6 factorial, x minus pi over 2 to the 6th power. So technically this is my answer, I just need to clean it up a little bit. Final answer, 6th degree Taylor polynomial for the function sine centered at pi over 2 is this. 1 minus, I'm going to leave the factorial even though I know that's just 2, just for effect, plus minus and this is it. All right. Now, this could look a little different. I could have a 2 on the bottom and a 4 factorial, which that's 24, and a 6 factorial, which I believe is 720. I could have all those numbers on the bottom. I could put them directly under the powers. You could rearrange the way it looks a little bit, but I like it like this because it reinforces our pattern. Our pattern is derivative over factorial times power. It's going to go that way every single time. And remembering that will help you form these. Okay, now if you want to get a head start on your understanding, which we'll talk about in class, get your graphing calculator out, graph f of x or y equals the sine of x, and then go into your calculator and do another graph of this polynomial and zoom in on pi over 2 and x equals pi over 2 and see what they look like right there. All right, so just have a look and start to guess, what's going on here. But like I said, there's understanding and there's steps. The purpose of this one is steps. So if you ever need to go back and look, you can always go back and refresh your steps. All right, so just to review, take the derivatives, plug in the center, and then start filling in this formula with the pattern, derivative, factorial, power, repeat. Some of the terms wipe out because the derivative was 0. Great, it's less terms, makes it a little easier. All right, so that's Taylor polynomials. Good section, big important section for us. You will get this on your AP exam, guaranteed, in one form or another. And we'll talk about all the different ways that might happen. All right, so this is the great nephew of Brooke Taylor. I'm out.